As each pump full of air is pushed into a steel tank, the pressure of the air in the tank will increase. More and more air is being pressed into the same space. The compressed air inside the tank pushes against the tank walls and against the gauge. The tank is a reservoir of compressed air. Even if the pump stops, the tank can deliver an even flow of air by adjusting the petcock. As the air pressure escapes from the tank, the pressure will drop. When the petcock is closed, the pressure remains constant. In this case, 25 pounds per square inch, the usual pressure in an automobile tire. This pressure can best be appreciated by showing its equivalent in weight, as demonstrated with this piston and cylinder sketch. 25 pounds per square inch of air pressure is exerting enough force on the bottom of the piston to support a total weight of 314 pounds. Now, 90 pounds per square inch is the pressure at which air brakes operate. By increasing the air pressure on the same piston to 90 pounds per square inch, we find it will support a total weight of 1,130 pounds. In other words, 90 psi of air pressure is exerting 1,130 pounds of force. How can this force be put to work? Let's insert a heavy rubber balloon into this plastic container and attach it to the wheel braking mechanism. What we're going to do is to blow up the balloon so that we can actually see the air pressure, the balloon, pressing against the linkage. We will get our pressure from the air tank, which is simulating the reservoir on large vehicles. The compressed air in the balloon can push the piston and linkage with enough force to actuate the wheel brake mechanism and apply the brakes. The air brake system of an automotive vehicle works just this way. The compressor, which corresponds to the bicycle pump, supplies the compressed air. It is driven by the engine. In this demonstration, we're using an electric motor. The compressed air is forced into two tanks. These two reservoirs ensure a sufficient supply of compressed air for any emergency. A safety valve is mounted on or near the reservoirs to protect the system and personnel in case excessive pressure should build up. Compressed air from the reservoirs goes to the brake valve, which is operated by the foot pedal. This is the brake valve, which is activated by the foot pedal. When the valve opens, air is permitted to rush from the reservoirs through the brake lines into the front and rear brake chambers located close to the wheels. Each brake chamber does the same job as demonstrated by the rubber balloon. This brake chamber is the air-applied, spring-released type. Disassembled, it consists of the following components: the end cover and retaining ring, the flexible rubber diaphragm, the piston or plate, and push rod. The piston release spring, the main body and mounting point. The diaphragm will move the push rod plate when compressed air is admitted into the chamber. It operates the brake shoe through the linkage. The linkage consists of a slack adjuster mounted on a camshaft. And a push rod which is connected to the slack adjuster with a pin. On the other end of the camshaft is the cam itself. When the push rod moves forward, it forces the slack adjuster to rotate the cam. This action spreads the brake shoes against the brake drum and stops the wheels. When the brakes are released, the compressed air in the brake chambers is allowed to escape through the brake valve. It is hardly conceivable that a load of this size can be stopped with just a little air. How an air brake system works can best be seen on this demonstration board. Air enters the system through the air breather on the compressor. The air breather ensures that only clean air enters. The compressor is similar to an internal combustion engine. Most compressors contain 2 cylinders, in each of which a piston is moved up and down by a crankshaft. The holes in the cylinder walls are the air intake ports. The piston serves as the inlet valve by opening the inlet ports to draw fresh air into the cylinder as it nears the bottom of its downward stroke. It closes them to begin air compression on its upward stroke. When the piston reaches the top of its stroke, the pressure is great enough to open the discharge valve against the pressure of its spring. This forces the compressed air through the line into the reservoir. Watch this cycle of operation carefully. Since the compressor is operating continuously and the engine is running, some means must be provided to prevent excessive pressure from building up in the reservoirs and to relieve the compressor of the strain of continuously pumping under load. That's the job of this section of the compressor known as the unloader head. It is controlled by a governor. The governor is connected between the main compressed air system and the unloader head of the compressor. The governor can be set to operate at a wide range of pressures simply by turning this adjusting screw. The usual maximum is about 105 pounds per square inch. Let's look at a cutaway view of a typical governor. The main component is a 2-way piston. This piston incorporates 2 valves, an inlet and an exhaust valve. The inlet valve is held closed by a spring and guide. Let's see how it operates. When the engine is started, air pressure from the reservoir increases in the system. You'll notice this air pressure is blocked by a spring-loaded valve. As the pressure increases and reaches the governor setting, or 105 psi, it overcomes the spring tension and moves the piston. 2 valves are operated by this piston movement. The exhaust valve is seated, closing the exhaust port. Simultaneously, the inlet valve is unseated and opened, allowing air pressure from the reservoir to move through the inlet port and around the piston and into the unloader head. This opens the unloader valves through their linkage. When the unloader valves open, the air passes back and forth between the 2 cylinders through the unloader cavity. Not enough pressure can be built up to open the discharge valve against the force of its spring. Air can no longer be forced into the reservoir. This action continues until the pressure in the reservoir drops to a satisfactory minimum, usually about 85 pounds. When this happens, the governor piston returns to its original position. This forces the inlet valve closed and cuts off the unloader head from the reservoir pressure. Simultaneously, the exhaust valve opens, allowing the trapped air to escape through the exhaust port. Compressed air is again forced into the reservoirs, and the pressure starts to rise. As you can see, there are two reservoirs in this air brake system. During compression, the air is heated. As it flows through the lines into the reservoir, the air becomes cool and its moisture condenses out into water. The first reservoir is called the number 1, or wet reservoir. It is mainly used as a moisture trap in which nearly all the water can be collected and drained away when necessary. The number 2 reservoir, the dry reservoir, drains off the remaining water and supplies dry, compressed air to the system. Normally, the reservoirs are drained every day. The compressed air feeds from the dry reservoir through two lines, one that leads to the air brake valve and one that leads to the relay valve. Both valves control the flow of air to these brake chambers located at each wheel. The air brake valve is connected to the brake pedal. The air brake valve, the heart of the air brake system, meters the required air pressure equally to all brake lines and chambers. This is a plastic mock-up of the air brake valve, sometimes called the brake apply valve. Let's disassemble it and find out how it works. The valve is operated by this plunger pushing against a pressure regulating spring assembly. This is the pressure regulating spring assembly. The spring pushes down on this airtight diaphragm. The diaphragm operates the rocker below it. This in turn operates two valves, the intake valve and the exhaust valve. When the brake is applied, air from the reservoir enters the intake valve. The exhaust valve permits the air to escape when the brakes are released. Let's stand it up now and look at a sketch of the action. When we press down on the brake pedal, the pressure regulating spring assembly forces the diaphragm down. This pushes down on the middle of the rocker arm, forcing it down. As the rocker arm moves down, it pushes against the tops of the two valves. Because the spring of the exhaust valve is weaker than the spring of the intake valve, the exhaust valve moves down first. This closes the exhaust port. As soon as the exhaust port is closed, the rocker arm pushes against the intake valve until it opens and compressed air rushes in from the reservoir. The compressed air can't escape through the exhaust port because it is closed. It takes the only other route open, through the brake lines to the brake chambers. The pressure in the brake chambers and the air lines becomes the same as the pressure under the diaphragm. Compressed air flows from the reservoir into the valve chamber until the force of the air pushing under the diaphragm becomes just a shade greater than the force of the spring assembly pushing down on the diaphragm. This forces the diaphragm up slightly. Because the intake valve spring is stronger than the exhaust valve spring, the intake valve moves up first. This closes the valve and stops the increase of pressure. But the exhaust valve remains closed. Its spring is too weak to overcome the force still pushing down from the brake pedal through the spring assembly. This is known as the lapped or balanced position. In the lapped position, both valves are closed. As long as the driver's foot pushes with the same force on the brake pedal, the brake valve will remain in the lapped position, and the pressure on the brakes will remain constant. If the brake pedal is now pushed down further, the valve will come to another lapped position, with a greater air pressure under the diaphragm and on the brakes. If the brake pedal is released a little, the exhaust valve will be allowed to open until the valve comes to still another lapped position. This results in a lower air pressure to the wheels. When the foot is taken off the brake pedal, the spring assembly is no longer pushed down upon the diaphragm and the rocker arm. The exhaust valve opens, allowing the air in the brake chambers and under the diaphragm to escape to the outside. You can't see the air escape when the brake is released, but a spoonful of powder held under the exhaust valve shows what happens. The front brake chambers are so far from the brake valve that the brakes will drag while the air is escaping through this long route. To prevent this drag, a quick release valve is used. This valve is located close to the front brake chambers and allows the air to escape much faster. When the brake pedal is pushed down, air rushes in from the brake valve, pushing the diaphragm down. When the diaphragm moves down, it cuts off the air escape to the outside. The compressed air surges through the two side ports, each of which leads to the brake chambers. When the pressure above and below the diaphragm is equal, the spring closes the inlet port. The center of the diaphragm keeps the exhaust port closed. This is the balanced or lapped position. When the brake valve is released, there is no pressure above the diaphragm, so the spring is able to return the diaphragm to its seat. This blocks off the passage back to the brake valve, but opens up a shortcut that leads directly to the outside. The air in the brake chambers escapes quickly, without traveling the long route through the air lines to the brake valve. On long wheelbase tractor trailers, the front brake chambers are close to the brake valve. The rear brake chambers are a long distance away. Yet the rear brakes must be applied at the same time as the front brakes and must release as quickly. The relay valve provides quick response for the rear wheels. It provides a direct compressed air feed from the dry reservoir to the relay valve and then to the rear brake chambers. This air feed is regulated through the control air line by the brake valve. Here is the action that takes place. When the brake valve operates, air under pressure is delivered through the line to the relay valve. The air enters the cavity above the diaphragm, forcing the diaphragm down and opening the intake valve. Simultaneously, the exhaust passage is closed, preventing the air from escaping. Instead, it rushes through the side ports into the rear brake chambers. As soon as the air pressure above the diaphragm is equalized by the brake chamber air pressure, the diaphragm is raised into its lapped position, maintaining the same pressure in the rear brake chambers that is maintained in the front brake chambers. Each time more pressure is applied or pressure released, a new lapped position is reached. After a long period of service, wear may produce a slight variation of pressure above and below the diaphragm. The bleeder or bypass port corrects this error. When the brake pedal is released, the air above the diaphragm escapes by way of the brake valve. The pressure below forces the diaphragm up. This opens the exhaust port and allows the air in the brake chambers to escape directly. All these actions take place at the same time. They have been slowed down for the sake of clarity. Watch how quickly this happens in normal operation. When the brake pedal is released, the air from the rear brake chambers escapes through the relay valve. The air brake line quick disconnect points are located between the tractor and the trailer. An emergency brake line is mounted on the right side of the vehicle. A service brake line is on the left side. When the trailer is separated from its tractor, or when the units are coupled and the air supply disconnected, safety brakes are automatically applied to the trailer wheel. As long as there is air pressure in the trailer reservoir, this safety feature prevents the trailer wheels from rolling. When the tractor air supply is again connected to the trailer, its pressure is applied to the emergency relay valve on the trailer. This valve releases the safety brake and permits the trailer wheels to roll. Now let's see how each unit of the air brake system is mounted on this tractor trailer. The compressor is mounted on the engine. The unloader head on top of the compressor is regulated by the governor, which maintains the required pressure in the compressed air reservoirs. On the back of the tractor, the reservoirs are mounted on the chassis. They trap the moisture in the air and store a ready supply of air at the required pressure. A safety valve is mounted on one of the reservoirs. Near the rear wheels, the relay valve provides for quick application and release of the rear brakes. Mounted under the brake pedal and under the cab floor is the air brake valve, which regulates the pressure required at the brake chambers. The brake chambers are mounted near the wheels. They actuate the braking mechanism. Located between the front wheels is the quick release valve. It provides a quick exhaust for the front brake chambers, preventing brake drag. When an emergency has arisen and traffic must be controlled, all brake components must function properly. Air brakes are the safest way to stop a really big load.